Hi everyone, my name is Ahmed and this is my teammate
Karim.
and we built Proteus. One of the biggest friction points in online shopping is that you can't really see how something will look on you. You have to imagine it or wait for delivery to try it on. And we wanted to change that, so we built Proteus. And Proteus is a platform, it's a real-time GPU powered virtual try-on system. You upload a photo of yourself and a photo of an outfit, which could be from your camera roll, could be from a product shot or a screenshot of an app. And within seconds you can get a synthesized image of yourself wearing that outfit. So no physical try-on required. And the whole thing runs on Linode Kubernetes engine. The front end is live at proteus-frontend-sci.versal.app, and you can try it live yourself. The backend with the GPU workers, Redis, and the database are all running on Linode Kubernetes engine. And we'll walk through the app and then how it's built and why it fits both Linode and the Kilo Hackathon tracks. And now Kareem is going to walk us through a demo of the app.
Yeah, so here's the app. We just first at the homepage. Obviously, you have to log in, but the homepage just tells you like how it works, the app features, and the flow and everything. And then we can just go right ahead and sign up. Just gotta create your username, your email. You gotta create a password, just regular stuff. And then once we do that, you have to log in, and we have a simple authentication flow with sign up and log in, and the sessions are cookie based. So once we log in, it redirects you to the user history where you have a form to create a try on. You create an outfit where you can upload two images, one of the user photo. So we're just gonna pick a model right here that we've already had saved up, and then we're gonna pick an outfit that we want to see on that model. And then the app accepts all image formats except HEIC, AVF, PNG, JPG, all the common formats. And then we have a handler that essentially like handles on all like non-JPG formats, and it converts it to it so that the model, the ML model can receive it and process it. And then just once in the form we can click try on, and then what that does is submits a job to the backend for it to process the outfit on the model, and it opens a WebSocket connection where it's like constantly listening for when that job is done, and then now it's just processing here, and wherever it's done, this usually takes like 5 to 10 seconds, and then after that, it's just gonna show right here the outfit on the model. And you can also click, we have a manual refresh button if that's taking too long or something, or if there's some sort of issue, and then we can find right here that the outfit has been applied to the model successfully, and this one looks great. But and also it keeps a history of your past try-ons, or like past VTONs as we call it here. And yeah, that's pretty much most of the product right here. And then even if we log out right now, and then if we log in again, if you just log in with the same credentials again, it should have the same VTON in your history. So if we go to history, and then it just has your past outfit try-on. So if you have a history of just like a couple outfits that you like and you want to compare them, you always have them in your dashboard as a user in our app. And that's it. I think that's most of our app flow.
Architecturally, Proteus is designed as a clean, scalable pipeline on Kubernetes deployed on Akami Technologies Kubernetes Linode engine. And we have a stateless gateway surface that handles authentication, secure login, and secure image uploads with pre-signed URLs and real-time WebSocket communication with the front end. So when a user starts to try on, the gateway drops a job into a Redis queue, and then the GPU worker nodes, they would automatically pull jobs from that queue and run the virtual try-on model and store the result in object storage. And they will push the result to a channel that the WebSocket would relay to the client. And then a key piece is that what if this queue gets too long, there might be a lot of latency, so that's why we have the arbitrator. It's a lightweight control surface that monitors queue depth and system load, and they would ask the GPU worker nodes to run batching instead on the jobs instead of like running them one by one. And as soon as the job finishes, a completion event flows back through the gateway to the user browsers, so the interface updates instantly without refreshing, and that's with the help of the WebSocket that is subscribed to a channel that listens to finished jobs. And the result is an event-driven architecture that is modular, resilient, and built to run real AI workloads at scale.
So I'm just going to talk more about hackathon alignment here. So for the Akamai Linode challenge, Proteus is a strong fit because our entire pipeline runs on the Linode Kubernetes engine. Our cluster hosts the gateway, GPU-powered Weaver workers, and the arbitrator control service, Redis, and PostgreSQL, with optional key-based autoscaling. We're running a real AI workload, the Cat Viton virtual try-on model, on NVIDIA GPUs using an event-driven architecture using Redis queues. The stack is fully open source and deployable, with Docker Compose for local development and Kubernetes manifest for production. And now for the Kilo challenge, we use Kilo code throughout development for code reviews, front-end guidance, and architecture decisions. We've heavily used the Minimax 2.5 model for the front end on our project, and it helped us refine our React interface, design a clean service split between gateways and workers, and then ship a stable deployed system. The result is not just a prototype, but a working GPU-backed platform with real-time updates running in production.
We're excited about where this can go next, from adding a Taylor processing stage to improving realism and speed. But even today, Proteus is a working platform that people can use, extend, and deploy themselves. If you're curious, check out the GitHub repo and try the live demo that we have for our website. And thanks for watching. We're excited to keep building and pushing virtual try-on forward.